All right, so we've got 3 times 4x minus 2 minus like a 5x minus 8 equals 8 minus 2x plus 3 in parentheses, right?
Right.
So the first step, you just kind of go from left to right. We need to kind of simplify everything and add like terms. Okay, so we're going to simplify. Simplify is like a catch-all phrase in math, isn't it? It's like, make it simpler. Add like terms. All right, so let's try that first. So before we kind of, try to solve the thing, adding and subtracting to both sides, just going to simplify first. So I'll multiply 3 in. That's a distributive property. You have 3 of these bags. And so it's 3 of everything in there. So 3 times 4x, 12x, 3 times negative 2, negative 6, right? Now the next one is interesting because it's kind of like you've got a negative touching a parenthesis. A negative touching a parenthesis. So we've got to think about that because it's kind of like, it's one thing if I say, okay, I've got like an apple and a banana in a bag and I put a 2 here, that means I've got 2 here's an apple, here's the banana, right? Here's the bag, right? And I put the number 2 there. That means I got 2 apples, and 2 bananas. Okay with that?
Uh-huh.
All right, so that makes sense. So I get 2a plus 2b. So that makes sense to us. What if you have the problem is what happens when I have a negative on the outside of the bag? Negative apple plus banana. So here's my bag. There's a bag, and inside the bag there's an apple, and there's a banana. See that? And I just say, look, subtract that. Subtract that bag. That's interesting, isn't it? Right?
We would have to add a 1 in front of it, though, right?
To put a 1 in front of it, that would help. Yeah. But what does it mean to subtract this bag? Like if you had this bag and I subtracted it, what am I taking away from you?
An apple and a banana?
Yeah, I'm taking away an apple and I'm taking away a banana. I'm taking away both of these things, am I?
Yeah.
Right. So like I'm subtracting an apple and I'm subtracting a banana. See that? Subtracting apple, subtract banana, right? And as you say, if you stick a 1 there and you multiply it in, negative 1 times a is negative 1a, negative 1 times b is negative 1b. And that works. That'll do the job as well, right? That's another way of looking at it. But essentially we're saying apply a negative to everything inside that bag. And you could have a big bag, like you could have like, I don't know, an apple, a banana, a cherry, a turnip, a peach, and like a raspberry or something. And you can subtract all of that. So if I put a negative outside all of this, what's it going to do you think?
It would turn the positives into a negative because a negative and a positive makes a negative.
Right. So I'm going to subtract the apple because I'm subtracting this is a bag of fruit. In the bag I got an apple, a banana, cherry, turnip. Actually, turnip's not a fruit. It's a root vegetable. A peach and a raspberry. All right? So it means I'm subtracting all of these things. Subtracting the apple, subtracting the banana, subtracting the cherry, subtracting the turnip, subtract the peach, subtract the raspberry. Make sense?
Yeah.
All right. Now, again, as you say, you can stick in a 1 there. And they go negative 1 times that, times that, times that, times that, times that, times that, negative 1 times everything. And it all gets negatived, right? Negative 1 this, negative 1. All right. So that's the thing that messes us up all the time. And like, there's no context here. Like we don't know what the heck what's a 5x minus 8 anyway? Nobody knows, We don't even know what x represents in the real world. That's part of the problem with algebra. It's abstract. But anyway, negative 1. We can stick a negative 1 there and multiply that in. And we get negative 5x. And negative 1 times negative 8 plus 8. Right?
Right.
Okay, equals 8. And then minus 1. I'll multiply that guy in. Negative 2x. And don't forget, negative 1 times positive 3 is a negative 3. Right? And so the highlights of the first line is that this -1 multiplied by this -8 to get +8. That's a highlight. And the other highlight is that this -1 multiplied by this +3 to get a -3. So those would be the two common errors that students would miss those. So those two things make sense at least.
Yeah, that makes sense.
Right, because if you get that, everything else you guys can do. This is the hard part of this whole equation. Just that this becomes a +8, that becomes a -3. If you guys can understand that, I'm sure you'll get all the rest, because you've done the rest ad infinitum a lot. You've had a lot of practice with that. So now we just gather like terms together. We got x's over here and numbers. So I got a 12x and minus a 5x. That'd give me a 7x, wouldn't it? Right? I got a -6 plus 8. 6 bad guys, 8 good guys. That would give me 2 good guys. Yep. And then add the things together here. That's a 8, a -2x and a -3. Let's stick those numbers together. 8 minus 3 is +5. And you've got a -2x. So you can write that 5 minus 2x. Or you could write it -2x plus 5. Both are correct. It doesn't matter. The trick is that's a -2x. Is that? Can I put down 2x? Would that be correct to call this a 2x?
No.
No, that's another mistake that students might make. So it's a -2x. It's a +5. You can write it this way or that way. It doesn't matter. And now we're back to that whole solve the equation when you have x's on one side and numbers on the other. And so now our whole trick is to back to that whole thing. Let's get x equals to some number, right? And there's lots of ways of going about it. What do you want to do?
I would subtract the -2x from the 7x.
So let's get rid of that -2x. Now, we wouldn't subtract, though. What would we do to get rid of a -2x?
We would add.
There you go. Add 2x to both sides. And don't forget to add like terms, right? Because 7x plus 2x is 9x. 9x plus 2 equals. And then we just have a 5 there. See that?
Yeah.
Now that line okay? And now we're back to the classic kind of basic first linear equation, and we can all get it from here. We just subtract 2. You guys have done this ad infinitum, and that is 3, and then we divide by 9, and then we get x equals, and I want you all to make sure to simplify that fraction there. Just because it's nice to simplify fractions because it makes it that little bit simpler.
Right, and it would be 1/3.
Yes, good. 3 goes once, 3 and 9 goes 3 times. If you can, simplify it. That's the trick. 1/3. Perfect. X is equal to 1/3. Yep. Yeah, so that's it. That's that one. Awesome question. Well done.